Good morning, everyone. It's a nice early morning to come. Thank you all for coming. I'm CJ Williams. I'm going to be talking about what's new in Windows Server 2012 networking. I wanted to just ask a few questions maybe to start off with. So how many people have actually run Windows Server 2012? Okay, so most everyone. How many people are running Hyper-V on that? Okay, good. How many people are using some of the offloads like RDMA or SRAV? So a few people like that. Good. VRSS. How many people have heard about Hyper-V Network Virtualization? Is anyone actually using it in labs or anything like that? Okay, look, a few people. Good. So, those are, well, we'll get started. I just want to kind of understand where the audience was, what they understood about 2012. So let me talk kind of about the agenda. So I want to talk a little bit about what we've done so far, where we're at with 2012, just to kind of level set, because that was a big release for us. And then I want to talk about what's coming in 2012 and then dive into 3 specific areas that we really focused on for R2. So when we look at networking and we have this Cloud OS initiative across Microsoft and across Windows Server, networking is really looked at as one of the bedrocks, right? You have networking, compute, and storage. And so we think networking and the work that we've been doing is kind of foundational to realize this Cloud OS vision. And so as I talk about, I'll be talking about a kind of a broad set of topics that are connected but are kind of in major areas. So when you look at what we did in 2012, it was a very big release for networking. We looked at several major areas. So the first is around continuous application availability, and we released a lot of new features in 2012. So how many people have used NIC teaming, the inbox NIC teaming? So quite a few people. That was one of the big requested features, and it was actually delivered in 2012. Then there's the SMB 3.0 multi-channel work, the quality of service work in the hypervisor switch, DHCP failover, really allow applications to be continuously available even in the face of network failure. And then we did a lot of work around the ecosystem. So we have the Hyper-V Extensible switch, which allowed third parties to plug in different type of extensions into the switch and enhance the capabilities. We also had a large set of hardware partners that released new products around 2012. We also had simplified multi-tenant infrastructure with the PVLAN work, with Hyper-V Network Virtualization, cross-premise connectivity. So a lot of work that we did to enable the multi-tenant data center. And then around high-performance computing, a lot of the offload work where it was actually hardware requirements, new hardware was required to enable it, but it really got the type of performance that you would expect in cloud computing. And then a bunch of work around operational efficiency. I forget the exact number, but there was a large number of new Windows PowerShell commandlets that were added. There was the branch cache and direct access work, resource metering and IPAM. So a lot of work that went into the 2012 wave. And that essentially set the foundation for the work that we're doing in R2. And you'll see a lot of the work that we're doing is really enhancements on existing functionality or taking what we already have and making it even better. And as part of kind of going from 2012, and even in 2012, but going from 2012 to R2, we spend a lot of time learning about our data centers themselves and what our data centers, do. So we have some of the largest data centers in the world with Azure and Bing, Office 365, and they run at massive scale. And so what we've been doing and continue to want to do is bring those learnings and bring those best practices from our data centers into our products. And so we really kind of focused around 3 big things. So the first is cutting cost. And obviously everyone wants to be able to cut cost. When we look at cutting costs, this isn't necessarily just reducing like component prices or something like that, because it's not something that we control. But it's really about maximizing the utilization of your existing resources. And that's one thing that I'll talk quite a bit about today, is we want you to be able to use your existing NICs, existing hardware, and just get better use out of them, be able to actually run them at full performance regardless of the type of workload that you're running. And then the second thing is really around choice and flexibility, right? You want to be able to choose from multiple vendors, have them work well together, and I'll be talking about some things that we're doing around that. And then the other thing is you really want to be able to take, especially if in a virtualized environment, take your data centers and make them, or take your VMs and make them runnable anywhere in your data center without having to totally reconfigure, totally redeploy, totally set up new functionality just to move those VMs around. And then the last thing is there's a big focus, especially in our data centers, around agility and automation, especially automation, making sure that things that you do all the time, things that you do constantly, tasks that have to be performed daily, you can just automate it and make it happen seamlessly. But then also making sure that that gets reported on and that any errors or anything like that get bubbled up. And so those are kind of the three big areas of learning that we've tried to take into this R2 release and kind of make those available for our customers. So that kind of sets the stage for what we're doing in R2. And so in R2, what we're really looking at is three big areas. I'll primarily focus today on the cloud scale performance and diagnosability. So we've done a lot of work in both the performance and the diagnostics area. So, and I'll talk about a number of new features that we've added or new enhancements to existing features that we've been doing. And that's where I'll put a lot of my time, and we'll show some demos of this stuff working so you can actually see it live. Then the second area is around a comprehensive SDN solution. And I'll talk about it, and then there's also a talk later today that you can go to find out more. I think it's about 1:30. And then the last area that we focused on is around core infrastructure enhancements. So this would be things like IPAM, DNS, and there's also a talk on this later in the week. So I won't spend as much time in these areas, but they're all very important, and these are kind of where the bulk of our work in networking have gone in for this release. So let me move on to cloud scale performance and reliability. So the first new feature that we've added is called virtual RSS. And so I think a number of people had used RSS in 2012, and it really allowed, from a host perspective, for you to get the best performance, right? Because you can now, even with high-speed NICs of 10 gig or 40 gig, you can take that traffic and not have it all processed on a single core. It can be spread out across the physical cores for RSS. And so the idea was to be able to take that same concept and apply it into a virtual machine, and basically allow for a virtual machine the same type of capability where you're no longer limited to the processing capability of a single core to process network traffic, but to really be able to spread it out in the virtual space and get near line rate performance even in the virtual machine. And so, in 2012, essentially, we introduced both RSS and dynamic VMQ, which both helped in different ways. But the focus of VRSS is really when you have one single VM or a small number of VMs that want to process a large amount of network traffic. And so especially when you think about like virtual network appliances, virtual gateways, things like that, network intensive applications that are running in a VM, this really allows those type of applications to run at their maximum performance. And so just an example of how it works, basically you have your physical NIC and it's processing packets. And without VRSS, what happens is it just gets pinned to a particular processor or virtual processor in the host. With VRSS, that now gets spread out both in the host and the guest. And so as a single core is being utilized heavily for network traffic, the operating system will automatically spread that traffic out across the virtual processors in the VM, and as such, it gets spread out in the cores in the host. And what it really, like I said, allows you to do is to take traditionally network-intensive applications that you would only run inside the host and run them inside the VM. And the big thing here is that no new hardware is actually needed to enable this feature. So we use the existing VMQ functionality in NICs to enable this. And basically, it's not set on by default because there is some overhead if you're not a network-intensive application. But you can turn it on inside the VM and get this capability. So we think this is, for a class of applications, is really going to allow them to move into the virtualized space and not get performance degradation like you might have gotten in previous releases. So the next feature that I want to talk about is NIC teaming. And as I mentioned, so NIC teaming came out in the 2012 timeframe, and the goal was twofold: to provide fault tolerance. So if you had a team of NICs and if one NIC failed, you would automatically be able to fail over to those other NICs and not see any outages. So that's one big area. And the other one is around load balancing, right? So if you have 2 or 3 NICs in a NIC team, you want to be able to use all the bandwidth available for those NICs. And so when 2012, for the load balancing mode, there were basically a couple different options that you could choose. You could choose Hyper-V port mode, or you could choose forgot the address hashing mode. And both of them had their advantages depending on what type of workload you were running. What we've done in 2012 R2 is we've added a new mode, which is called the dynamic mode. And it basically gives you the best of both worlds. So in 2012 now, you'll be able to pretty evenly spread out your traffic both inbound and outbound. And one of the big ways that we were able to enable this was that on the outbound mode in 2012, we were only able to spread out based off of TCP flows. And so if you had a VM that, one particular VM that was taking a lot of bandwidth and had big flows, so you were copying over VHDs, or you were downloading a media file or something like that, then it would be pinned to one particular NIC. In the dynamic mode, we're able to actually break up those TCP flows into what we call flowlets, which gives you much finer grain ability, or gives the operating system much finer grain ability to load balance across the NICs. And so I'll kind of explain. So in 2012, how it worked is if you had a flow, it would be pinned to a particular NIC, and it wouldn't actually spread out. And how you would get the spread is you would have multiple VMs or you would have multiple flows. But if you had an imbalance, one flow was very long-lived and was downloading a lot of traffic or uploading a lot of traffic, then it would be pinned to a particular NIC, and it would, not give you the optimal load balancing. In 2012 R2, we now break it up into these flowlets, and we're able to more evenly spread across all the NICs, regardless of what type of workload you're running. And so we've seen pretty big improvements based off your workload here. And so this is, one of those things where we took a feature that was much requested in 2012 and we got a lot of good feedback on, and we just made it even better. So the next area that I want to move to is around ACLS. And so how many people use ACLS in the Hyper-V switch today? A few people. So one of the things that we basically, the feedback that we heard was in 2012, the functionality was fairly basic. So you could block and allow traffic based off of just the source and destination VM. And for some type of ACLS, that's good, but it doesn't kind of provide you the richness that most people want to use with ACLS. And so in 2012 R2, we added several new features. So the first one is that we allow to, or that we enable it to allow or block traffic for specific workloads. And you can filter it based off the network address, the application port, or the protocol type. So you have much more capability of deciding how you actually block traffic and what specific traffic you block. It's not just an all or nothing for a particular VM. And then the other thing that we enabled was basically stateful packet inspection. So we actually maintain state of the packet and understand the connection And so, much like more traditional firewalls where you get the stateful packet inspection, we've now enabled that on Hyper-V switch ACLs. And so, yeah, you can essentially block and add ACLs, or block and add traffic as you need based off the different types. So the next area that we worked on was basically remote live monitoring. And so, one of the things in 2012 is that remotely monitoring the traffic is fairly difficult, which means if you want to monitor traffic on a particular VM, you have to log on to that VM, hope that it has netmon or message analyzer or something like that. And what we've enabled in R2 is basically the ability to remotely monitor the traffic, but do it in a live or at least near live fashion. And this allows you to, both mirror and capture traffic for either remote or local viewing. And underlying what we use ETW and WMI to actually transfer the data back and forth. And then with Message Analyzer, which is essentially the next release or the new version of netmon. And how many people know about Message Analyzer or have used it? So a few people. Message Analyzer is actually available in beta form today, so you can go out and download it and kind of start using it and playing around with it. But with R2, you'll actually be able to use Message Analyzer as essentially this front end for remote monitoring. And the GUI experience is fairly similar to what it is in netmon, so you can capture this traffic, you can save it off for offline analysis. You can do things like filtering based off a wide number of attributes, be it traffic type, IP addresses, by VMs. So you have all this capability of filtering what from a network perspective is probably a large amount of data, and you can like I say, you have different ability to do this either live, or you can do it you can do the live monitoring and then save it offline for additional viewing. And so here, there's really a wide range of functionality that we've added. And there's a number of things that I didn't talk about specifically, but it'll be in other talks that we have throughout the week, especially around Hyper-V Network Virtualization and the diagnostic capability that we've added for that. So what I want to do is I want to ask Gabe Silva, PM on our team, to come up and do some demos for you so that you can actually see a lot of this stuff working live. Gabe, let me switch over for you.
Thanks, CJ. Hi, everyone. My name is Gabe Silva, and I'm a PM on the core networking team with CJ. I get to do the fun part of the presentation today. I'm going to show you guys some demos and show off what we've done in R2, if I can get my password. So the first demo I'm going to show today is the NIC teaming functionality. Oh, I'm sorry. Go ahead. Is that better? Can everyone hear me? Okay, sorry about that. So the first demo I'm going to do for you today is the LBFO, the NIC teaming demo. We added a new mode called dynamic mode. But first, I want to show you what it looked like when in Windows Server 2012. So this graph on the right is performance monitor. You're going to see that we have the receive traffic. We have 4 NICs on this machine, and the receive traffic will be on the left-hand side, and the send traffic will be on the right-hand side. The NIC teaming properties are here, and you see I have address hash selected. We get a good spread outgoing, but incoming is all on one NIC. So we also had Hyper-V port mode. So happens that we have 3 VMs on this host. You see that now we have this nice spread among 3 NICs, but we still have another NIC available that just isn't being utilized. So what we did with dynamic is we now break it into flowlets. So the outgoing traffic is now spread among all 4 NICs, even though there's only 3 VMs. So continuing with the performance, I'm going to show VRSS. So before, to a VM, you would see that, well, let me first take a step back. What we have here are two hosts. We have two computers connected back to back with 10 gig NICs. We have the sender here on the right and the receiver on the left with the VM here. I'm using an application called NTTCP that basically simulates workload traffic and creates multiple TCP connections. So in Windows Server 2012, the traffic coming in, let me just make sure the traffic starts. There we go. So the traffic coming into the VM was bottlenecked on one processor. You would see throughput of roughly 5.4 gigs, but we have 10 gig NICs and we can't fully utilize them. Furthermore, we saw on the host, we were still affinitized to just one processor. So what we wanted to do is be able to use all the resources within the host without having to put new expensive hardware in there. So we did a lot of work advancing the VMQ algorithm and enabling RSS inside of the VM. And it's really just as easy as enabling RSS. So we'll go ahead and run the same test. We'll start the receiver and then the sender. And you'll see that just like in a physical host, the traffic is now spread among all cores. And our throughput is also jumping up above the 5 gigs. Not to mention, in the host, we expand on the dynamic VMQ capabilities, so if a core starts to become pegged or overutilized, we start moving those flows off of that core and onto available cores for processing. So now that I've shown a little bit of the performance, I want to show you guys the remote live monitoring. So I'll come over here to my sender now. And in the sender, I have message analyzers set up. So what I did is I've added a host here, which is just our host receiving, and actually let me start some traffic here. And this is just the host receiving the traffic. And I have multiple ways to configure the traffic I want to see. So I can click on Configure, and it'll bring up the NICs inside of that remote host, and also the different filters I can apply. So I can apply truncation, I can check just the ingress traffic or the egress traffic. I'm going to go ahead and leave them all on for now. And we'll go ahead and just start. And it'll take just a second, but because it's not actual live monitoring, it's near real time. But you'll see that the packets will start to flow, and you'll see what the host is actually, the receiver is actually receiving, hopefully. I'm sorry, I can't hear you.
Yeah, so
Message Analyzer is, but you can only run it on a blue host.
Windows Server 2012 R2. Can you monitor? So if you're running on a 2012 R2 host, can you monitor?
No, it's not backwards compatible. Right. No, so you can only monitor the R2 host or R2.
Not the remote part. So you can run, I believe, Message Analyzer. I forget exactly all the versions that it's compatible with. But you can run Message Analyzer on multiple versions of Windows, but the remote part of it is only enabled when you're remoting to a 2012 R2 host.
Yeah, I'm actually running it right now on just Windows Server 2012. It's not an R2. That's the Message Analyzer portion of it. Let me see if I can't get it.
Because as I mentioned, how it works is it uses ETW and WMI to actually get that traffic off of the remote machine. And that functionality that's needed to actually get the traffic off of the remote machine is only in R2.
Oh, Message Analyzer has stopped working. All right, we'll go ahead and move on.
Yeah, what's a demo session without at least one crash?
All right. And finally, I have one more demo for you guys, and it's a new functionality that we implemented called test net connection. We had seen that some of our diagnosability tools were a little outdated, like ping. How many people here use ping? Everyone's got to use ping. So we wanted to make ping better. We wanted to incorporate more tools into ping so you can get more information. So we implemented a new commandlet called test net connection. And we'll connect here to your favorite site. And what it's going to do is it's going to give you a ping, but along with the ping, it's going to return a lot of information. So here you see the ping failed, it timed out. Well, we really don't know why it timed out. You can run a trace route and see maybe where it was blocked. But what it also gives you is it gives you the remote address. So it does a DNS lookup. It tells you the interface alias and the interface that you actually used. So the ping didn't succeed, but let's see if we can connect to the TCP port. So here you see the ping still did not succeed, but we do have TCP connectivity to Microsoft.com. It's very common for servers to block pings. So if you want more detailed information, you can add the information level, detailed. It's going to run the same test, but it's going to give you more results. So if you were actually running IPsec, it would give you the applicable IPsec rules and the network isolation context, whether it was internet or intranet. And lastly, we also added traceroute to this, so it becomes an all, and traceroute will take a little bit to run. So unlike traceroute, it has a maximum hop limit of 8, or of 20, I believe. So, and it'll return back all your hops in that route.
And
yeah.
So to repeat the question, can this trace or testnet connection run on 2008?
No. No, this is a new feature with R2, so it's not backwards compatible.
So I mean, it can connect to a 2008 machine,
yeah.
but the commandlet can't run from a 2008 device. And then I think also, so it's not just HTTP that you can connect through, right? There's a number of other protocols.
You can run any protocol. This just happens to be an alias that we use for HTTP. You can also hyphen protocol and add whatever protocol, and we have other popular ones, SMB.
I think RDP.
And RDP. Yes, yeah. So as soon as this traceroute finishes, I'll run any port you want and just show you that. Test connection is a wrapper for ping, almost. So test net connection just has a couple more features. We added, like I said, traceroute, and it's got the HTTP ping as well on there. So, and just to show the gentleman, protocol 8080.
Sorry, can you what? Yep. I don't know that it'll respond from this machine. We might not allow it.
We could do get help.
Or you can also, Gabe is showing basically where it's pinging websites and that kind of stuff. You can also ping servers inside your data center. So, I don't know if on one of the test ones it.
Who responds? Does Google respond?
I don't know. We can try. Yeah. Yeah.
I don't know the IP address.
Yeah. Hey, this is a first.
There you go. it comes back.
Audience control demos. Just tell us what to do, and we'll try to demo it and see if it works.
In the last.
Yeah, just do tab completion.
It's port. Sorry, I'm putting protocol in its port.
Ah.
Sorry about that. So it didn't respond back to port 81. Any other questions? Yeah, it would.
Yeah. So and there's a number of other options that you can choose, and so yeah, this is really about enhancing kind of the ping functionality that's built in, and internally we call this the super ping feature. So this adds a lot more features that you would kind of expect to be able to diagnose issues. Question? Do we have an alias pre-built in for the testnet connection?
Yeah, TNC. Yeah, so you can just TNC. And we're trying to get a TNC will automatically ping a server that we've set up in Bing. I'm not sure if it's completely up yet, but if you just need to test your connection quickly as possible, just type TNC and you can go from there. Yeah.
So is it available on Windows 8.1 on the client side, essentially? Do you know if it's available on the client?
Yeah, it's available on the client. Yeah, it's client and server. Right.
Okay, thanks, Gabe. So, as you can see, from a performance side, our real focus was to take your existing hardware, your existing capabilities, and especially the features that were added in Windows Server 2012, and then build onto it such that, the same workload, the same hardware will just perform better with 2012 R2. From a diagnosability side, what we looked at was, a number of different scenarios, whether you want to be able to remotely look at the traffic that's happening on a machine, or whether you want better diagnosability around kind of basic connectivity, or even, as I mentioned, we also enhanced the diagnosability of Hyper-V Network Virtualization, which we didn't talk about as much today, but we basically wanted to take a lot of the features and just essentially improve upon them in 2012 R2. So now let me move on to essentially our SDN solution. So when we look at SDN, and like I said, there's an entire talk about this later today. So if you want to get more information, kind of a view, just not from a technology point of view, but also from a partner perspective and some other things, you can come to that talk. But from a technology point of view, which is really what I want to talk about today, when we look at SDN, we look at kind of three main promises that we think the network should be able to provide. So the first one is flexibility, the second one is automation, and the third is control. When we look at what we want the network to be able to provide, we want it to be flexible such that you can move workloads around your data center regardless of what the underlying network connectivity looks like. Whether you have an L2 network or an L3 network or something like that. From an automation perspective, sorry, just getting over a little cold. From an automation perspective, you really want things to just happen. And so, if you are moving a VM from one machine to another, you just want the connectivity to move along with it, right? You don't want to have to reconfigure your VLANs, you don't want to reconfigure your switches, you just want the connectivity to stay. And then from a control perspective, you want to be able to set things like what is the QoS that this particular VM is going to get, or what are the underlying functionality that the Hyper-V switch exposes up to the VM. And when we look at what we provided in 2012, there were basically four main areas that we focused on in 2012. So the first was Hyper-V Network Virtualization, then the Hyper-V Extensible switch, System Center Virtual Machine Manager, which provided a lot of the automation aspects of it. And then we worked with partners to basically extend the SDN solution. For 2012 R2, what we've done is we've added a couple key pieces of functionality. So the first is network switch management. So how many people have heard about OMI, or data center abstraction layer? So a number of people. So this is really, bringing it into this entire SDN solution. So now not only can you configure and manage your virtual switch that's sitting on your host edge, but now you can start to manage your physical infrastructure as well as kind of one holistic scenario. And then the other thing is that we added was a number of built-in software gateways. So especially with Hyper-V Network Virtualization, what you have is, you have a virtual network, and the only way to kind of get out of that virtual network and talk on the physical network, or talk site to site, or talk out to the internet is with these gateways. And so in 2012 R2, what we did is we built in a number of these gateways directly into the product so that you get them kind of out of the box. And when we look at our SDN solution overall, not only do we have kind of these promises that we think the network should provide, we have principles on which we build our SDN solution. So the first is we want it open, extensible, and standards-based. So, from the Hyper-V Network Virtualization perspective, we're using NVGRE, which is Network Virtualization Generic Routing Encapsulation, which is an industry standard that we use for the actual encapsulation of the virtualized traffic. For network switch management, we're using the DMTF standards around how to manage physical switches. So a number of, and then with the Hyper-V Extensible switch, we have open APIs which third parties can come in and build their own extensions. And so, really open, extensible, and standards-based. We want it to be built in and production ready. So what we deliver in the box, while we continue to want to work with partners, and partners extend and enhance our solution, we want what we ship in box to be usable in production and available for customers. And then we think a big thing is that it's not only just innovation in software. A lot of people, when they talk about SDN, they just think about what can be done in software. We think it's actually, to get the best overall solution, it's innovation in both software and hardware. And so, as we look at things like network switch management, we want to bring both the virtual side, or the software side that's sitting on the in-host, into our SDN solution, but we also want to make sure that the physical infrastructure is included in there. So when you get things like automation, that it's not just automating the virtual side of things or the software side of things, but also the hardware and the physical infrastructure. So let me drill down into a couple areas, and I'll particularly just focus on things that are essentially new for 2012 R2. Like I said, come to the SDN talk if you kind of want more of the complete picture. But when we think about Hyper-V Network Virtualization, and it's a fairly new technology, so I'll spend just a little bit of time talking about it. Essentially the thought is that you have these virtual machines, or you have these physical hosts, and they were virtualized into virtual machines such that you could isolate the customers from each other. You could run multiple workloads on the same physical host without them, necessarily impacting each other. So from the network virtualization side, it's very much the same concept. You want multiple networks to be running on the same physical infrastructure, and you need some virtualization layer in which to separate and to isolate these networks in the networking case. And so basically how we do it with Hyper-V Network Virtualization is we use essentially the overlay approach. So we take a network, or we take the network, the virtual network, and we overlay it on top of the physical network. And we do this by encapsulating the packets, and we use, as I mentioned, network virtualization with using generic routing encapsulation as the encapsulation format that we use. And what this really solves is it solves kind of two big challenges. So the first is VM mobility. So now you're no longer limited to migrating VMs across just the same L2 domain. You can migrate it anywhere within where like System Center Virtual Machine Manager is actually managing the machine. So anywhere where you have connectivity, you can migrate that VM and you're able to still seamlessly communicate with it. Then the other thing that it allows is because it uses the overlay method of network virtualization, is the customers can bring their own IP addresses. Especially in the multi-tenant environment where you have enterprises coming on to a hoster or to Azure or something like that, they might already have their own IP addressing schemes. And what we want to allow is for that same IP addressing scheme to be brought onto the hoster or Azure. But even in the enterprise case where you have things like you want to have a production and a test environment, and you want to be able to use the same IP addresses for both of those environments, we allow that ability where even on the same physical network, inside these virtual networks, or between virtual networks, you can have overlapping IP addresses. So you can bring the exact same network topology and IP addresses into these virtualized networks. A question? Yep.
Is NVGRE going to have similar, or does it have similar capacity planning implementations?
Yeah, so the question was, with VLANs, you have 4,096 VLANs essentially, and does NVGRE have the same limitation? No, we actually use a 24-bit identifier, so we have. You could theoretically run out of them, but there's a lot of virtual networks that you can have. And the virtual networks are essentially unique within a data center. And so, if you have multiple data centers, you can multiply that out. So, realistically, the chances of hitting that limit are fairly low. So, the base functionality of Hyper-V Network Virtualization was delivered in Windows Server 2012. We've now enhanced what we did in 2012 with a couple of key features. So the first one that we enabled was dynamic learning of customer addresses. So within VGRE, you basically have two packets within the same packet. You have what we call the customer address packet, which is the inner packet, and you have the provider address packet, which is basically what the physical infrastructure sees. And so what we can do now in 2012 R2 is dynamically learn these IP addresses. And so it enables a couple of key features. So the first big one is that it allows for highly available hosts. So you can use guest clustering and host clustering inside a virtual network. And then you can also do things like DHCP inside the virtual network. So the customer could run their own DHCP server. The second area that we really focused on in R2 was performance enhancements. The two big ones being NIC teaming integration. So all the work that we just talked about for NIC teaming now gets brought over into the Hyper-V Network Virtualization, or the network, or the virtual network. And so even if you're running Hyper-V Network Virtualization, you can use the load balancing and failover features of NIC teaming. And then the other thing is, because we use this encapsulated packets, most existing NICs can't do the standard offloads on those type of packets because they're all coming in with the same provider address, and they're not able to look inside the customer address packet, which is really what you'd want to be able to do the offloads on. And so we've been working with a number of NIC vendors on bringing what we call these NVGRE task offload enabled NICs to market. And so a number of partners have now are delivering these, including Emulex and Mellanox. And so we see pretty impressive performance gains where essentially you're seeing now near line rate traffic on 10 gig NICs for this NVGRE traffic. And so there's no longer any kind of performance impact of using NVGRE. And then the last thing is we have essentially enhanced diagnostics of these virtual networks. Things, kind of the flavor of what they look like is on these VMs, because we have this overlay network on top, a admin that doesn't have access to those VMs can actually validate that those VMs have connectivity without having access to the VMs. But when 2012 R2, we've added a new PowerShell commandlet that basically lets them act like they are the VM, but have all the traffic available to the admin. And so they can actually validate that VMs in these virtualized networks have access or are able to communicate with each other without ever having to send traffic up to the VM itself. So that's Hyper-V Network Virtualization. The second big area that we worked on is this Hyper-V Extensible switch. And so the Extensible switch was something that we delivered in 2012, and it added a lot of benefits. So, essentially it was an open platform for plugins, and there were different type of plugins that people could create. Capture plugins for things like monitoring or billing or something like that. Filtering extensions if someone wanted to build an advanced firewall or some type of extension like that, and forwarding extensions. And kind of the two big forwarding extensions that partners had delivered on was Cisco had delivered the one in the Cisco 1000 the Nexus 1000 V, and that actually they announced yesterday is now fully available for release. It had been in beta for a month or so, but now it's actually available for release. And then NEC had built an OpenFlow extension inside, which actually made the Hyper-V switch essentially an OpenFlow enabled switch. And so we have a number of these extensions that have been built, but one of the things that wasn't supported was that because Hyper-V Network Virtualization was sitting below the virtual switch, these forwarding extensions only saw essentially what we call these customer address packets. So they only saw the packets that the VM saw. They didn't see the packets that were actually going on the physical infrastructure. And so what we did is in 2012 R2, we moved Hyper-V Network Virtualization into the virtual switch, and now third-party extensions can process on both the provider address packet and the customer address packet. And it allows several kind of key features. The first being what we call this hybrid forwarding. And so, you can think of a scenario where, you have, let's say, the Cisco Nexus 1000 KV, and it wants to virtualize or it wants to manage all the non-virtual traffic. And then you also want to run Hyper-V Network Virtualization for some of the traffic. And so we allow this where both Hyper-V Network Virtualization and the third-party extension can manipulate the packets and can forward packets based off the different packet types. The other thing is, as I'd mentioned, extensions can now view both the customer address packets and the provider address packets. And so, from a firewall application or from a billing or monitoring application, you can see both of these packets and can now manipulate either one, or can, in the firewall case, you might want to drop based off of the provider address in some case or the customer address in another case. From a monitoring, you can provide information, in either space. And so it allows for a lot more capabilities in the extensions themselves, and that they can essentially coexist with Hyper-V Network Virtualization. And then the other thing that it allows is it allows third parties to actually bring their own network virtualization. So, while we have the built-in Hyper-V Network Virtualization, Cisco can now bring, let's say, VXLAN network virtualization, or NEC can bring their OpenFlow network virtualization technology, and you can use it with Hyper-V. So the next area that I want to talk about is around the standards-based switch management. And so, as I'd mentioned, basically how this works is you have these standard SIM models which come from the DMTF standards body that describe how different type of devices should be managed. And in this case, they describe how switches should be managed. And once we have switches that are running OMI, which is a Microsoft open source technology that third parties can pick up and kind of get a lot of the infrastructure, they can now be managed through PowerShell, and then also SCVMM has capabilities of managing these type of devices. So on the PowerShell side of things, there's a wide variety of capabilities that it can do. Create VLANs, set VLANs, enable ports, disable ports, configure BGP, a lot of other things. SCVMM, kind of as an initial release, has targeted one of the biggest things that we heard from customers, which is essentially ensuring that the VLANs on a Hyper-V switch and the VLANs on the physical switch actually match up, so that you can ensure that, let's say a VM moves from one machine to another and it's on a particular VLAN, you can validate that physical switch actually has that or is configured to use that VLAN, and ensure that the communication will be able to flow from the VM automatically, and then you get notified if there's any configuration mismatch, and then VMM can go and fix that. And so, the things that the problems that it really solves is it allows now a common interface to manage multiple network vendor switches. Which, from an SCVMM perspective, will allow them to build, more and richer kind of network switch management over time. Then also from a PowerShell perspective, because you can use all the kind of rich automation capabilities of PowerShell, now you can automate a lot of your common tasks for managing switches. And then in 2012 R2, we'll actually have a logo program for these network switches. So that, if a switch is logoed, that it will work with PowerShell and SCVMM. So we think it brings a lot of capabilities to the customer, and then a lot of the benefits that you get from the logo program of the testing that we do and the validation that we do, that it just works with our software. So the third thing that I want to talk about is these built-in software gateways. So as I mentioned before, one of the things in 2012 is that we didn't have any built-in software gateways. And so if you wanted to use Hyper-V Network Virtualization, you would have to go get a third-party software or third-party gateway, even to do, let's say, just basic validation of and evaluation of Hyper-V Network Virtualization. In 2012 R2, what we've done is we've built three inbox gateway, or we've built one inbox gateway that has three kind of big areas of capability. So the first one is a multi-tenant aware VPN site-to-site gateway. And basically what this means is with one gateway VM, you can support multiple tenants. And you can support site-to-site connectivity. Also, the same type of multi-tenant aware NAT access or NAT gateway for internet access, and then a basic forwarding gateway if you want to interact with physical resources inside the data center. So those are kind of three broad roles of gateways. And we have a talk later today with SCVMM where we go into depth in these gateways that we've built in and kind of the capabilities that they provide. So what I want to do is ask Gabe to come up again and show one of the gateway demos, which is essentially a point-to-site demo. So Gabe?
Thanks. So I'm going to show off the point-to-site demo. And what we have here is we have two clients trying to connect to their resources inside a public cloud where their web servers are being hosted. So you can see here we have two clients, a red client and a blue client. We have the VPN set up on both, and they're both using different technologies. So the red client is using IPv2, the blue client is using SSTP. And as CJ was saying, what makes this possible is actually the cloud gateway. So we have a gateway here, and you can see that inside this gateway, we have multiple compartments. We have compartment 2, which is hosting our blue VLAN, and compartment 3, which is hosting the red VLAN. One of the biggest draws of HMV is that you can actually bring your own addresses. So you can see that the RAS servers here for the blue client is the same as the red client, as well as their subnet addresses. So what we'll do is we'll now connect Actually, before I connect, I want to show you guys that I'm not getting any connectivity. So you'll see that we're trying to connect to the resource, and we can't get to it. 30.1.1.3, and it'll be the same with our red client. And we still can't connect. So we'll connect here, and we have everything already set up to connect. And we'll try connecting again to our red server. And you see we can now connect. And on the blue app, if we try to connect, we still don't have connectivity. On our blue client, we still have to go back and connect to the VPN server. And once it's connected, he'll have access to their resources in the cloud.
Yep.
Mm-hmm.
So, if that's on the server, with that connection, can I set that connection to be established also as the server reboots?
Sorry, so the question was...
Server on the red network,
Yep.
network, so the red server reboots, and then it comes back up. I would like that one to reestablish that again.
So basically the question is, if you have, let's say, the red server, as you have it set up, and it goes down, can you have it automatically reestablish that VPN connection?
He said the answer is no.
Let me just ask, so are you saying if the VPN server goes down or the red app server goes down?
The red app server goes down when you enable the VPN connection.
Yep.
If I have a server that wants to connect to the whole data center, and that one goes down, and the server comes up again, I would like that to reestablish the server to the data center.
Right. So if the VPN server is still alive, you can connect into that virtual network, and then, well, are you saying the VPN server? Okay. The red client? Oh, okay. The red client.
If the red client reboots, I believe you have to reestablish the connection.
Yeah.
Yeah, you're going to have to. Yes.
Yeah.
Yeah. You got.
Maybe if you want to come down, because I don't know that I fully understand. So maybe afterwards, if you can come down, because I think it might work, but it probably takes some discussion on exactly what you're thinking about.
So, are the compartments roughly synonymous to VRFs?
Yeah, so basically the question is, are compartments roughly equivalent to VRFs? So basically, so I mentioned that these are multi-tenant gateways, and basically what that means is that you can have multiple tenants even if they have overlapping IP addresses inside one Windows VM, right? And so what these compartments do is basically it isolates the routing domain, right? So in this case, it's probably roughly the same, but basically it allows, each compartment is an individual routing domain. So while within a compartment you can't have overlapping IP addresses, two compartments can have the same overlapping IP addresses.
Any other questions? Thank you.
Thanks, Gabe. So, like I mentioned on SDN, so, we really think SDN is about, three big promises that the network can give: flexibility, automation, and control. And we think the technologies around Hyper-V Network Virtualization, the Hyper-V switch, the new switch management functionality, these cloud gateways, and SCVMM really enables you to take our SDN solution today and build it out inside of your data centers and run it in production. So the next area that I want to talk about, and I'll spend just a bit of time and then we'll have some time for questions afterwards, is around the core infrastructure enhancements. And so in 2012, we released this IP address management functionality in box. And this allows basically for integrated management of IP addresses, domain names, device identities, and it works very closely with existing Microsoft Server roles like DNS and DHCP. And it allows for quite a bit of information, and there's a whole talk about this later in the week. So I won't drill into a lot of details, but really focus on what we added in Windows Server 2012. So probably the biggest addition is now you can not only manage IP addresses in the physical space, so in these, let's say, in the Hyper-V Network Virtualization scenario, not only in the provider address, but you can also do it in the virtual network. So the customer addresses you can manage also, which allows enterprises that have a mixture of physical and virtual networks, they can now have a unified IP address management solution across those. The other thing is it now more deeply integrates with System Center Virtual Machine Manager, and it allows for these network configurations to be both imported and exported into SCVMM. And it enables synchronization with Active Directory sites and subnet information between SCVMM and Active Directory. And so basically, what you're seeing is the core functionality was delivered in Windows Server 2012, and now we're enhancing it and enabling new scenarios in 2012 R2. So just as a recap, for networking in Windows Server 2012 R2, there were 3 big areas that we focused on. So the first being cloud scale, performance, and diagnosability. And really our goal there was take the existing work that we'd done in Windows Server 2012 and enhance it. And so we didn't add any new kind of hardware capabilities or hardware offloads because we had added so many in Windows Server 2012. But we really wanted, from a performance perspective, to allow you to take your existing hardware and get more out of it. And kind of the big areas that we did this in was with VRSS and NIC teaming. Then from a diagnosability perspective, we added this ability to do remote live monitoring. We enhanced H&V diagnostics, and we added this new testnet connection that allowed you to get much richer information about what the connectivity looked like with inside between machines. And the second area was really to enhance our SDN solution to make it more customer ready and more production ready. And here we made enhancements to Hyper-V Network Virtualization and the switch extensions so that they could coexist. We also enabled these cloud gateways, so now you could completely run Hyper-V Network Virtualization with just in-box capabilities. And we also added this new switch management so that you can now manage both the virtual switch and the physical switch using very similar mechanisms. And then from a core infrastructure perspective, we made enhancements to IP or IPAM and to DNS. So I do want to mention, there's a number of related sessions that drill down deeper into software-defined networking, into how VMM manages networking, and Hyper-V Network Virtualization. And then you can also find us later tonight at Ask the Experts or the networking booth in the lab. So now looks like we have about 10 minutes or so for questions. Any additional questions that people had? Okay. Thank you so much for coming.